What's going on, everyone? Welcome back to the channel. In today's tutorial, I'll be showing you how to upload data from your Raspberry Pi Pico W to AWS DynamoDB. For those of you guys who don't know what AWS DynamoDB is, it's pretty much Amazon Web Services version of a NoSQL database. And the reason we want to learn this and implement this is because it has many benefits to us in IoT applications. One, it is incredibly scalable. Two, it has a very low latency performance, so we can upload data quickly with this software architecture stack. And also there are many automation tools in AWS that we can implement once our data is in AWS for some data visualizations and other things we want to do with our data. So integrating it with the Raspberry Pi Pico W can really bring a lot of benefits to your IoT applications. And I'll be showing you step by step in this video how to do that. Okay, so before we get into the nitty gritty, let's just go over a high level overview of the architecture we'll be using today to make this happen. Now, as you can see here, we have the architecture in front of us, and it may seem a little intimidating, but really it's not. It's just mostly a connection between AWS services. And if you are a beginner watching this, you should really embrace this because AWS is a really powerful tier in developing software applications, and it's used a lot in practice. So I highly suggest you learn it and become familiar with it. So we'll just walk from left to right here in this diagram. So as you can see, initially, simply what we're doing is we are just getting sensor data on our Raspberry Pi Pico W in MicroPython. I am integrating the MPU6050 accelerometer for today's video, but really you can use any sensor you want. I'll link this MPU6050 down in the description below. It's just a really popular and easy to use accelerometer, probably one of the most popular DIY sensors for the Raspberry Pi Pico W and Arduino. So once we have that data ready on our Raspberry Pi Pico W, we are just going to send it over the internet using the MQTT protocol, which is just a really popular IoT protocol. I talked a lot about it on my channel. And so we'll be using that in MicroPython to send data over the internet to AWS IoT Core. So this is where Amazon begins to handle all the processing for us. So this is the first layer in our AWS journey here. So this is just Amazon's version of their IoT service. And really what it allows us to do is to easily manage messages from the MQTT channel from our Raspberry Pi Pico W. So once we get messages over that channel, over the internet, what we're going to do is we're going to create something called an IoT rule. And this is really simple. This is just a matter of clicking a few buttons. And we'll be telling AWS to, once we get the data on AWS IoT Core on the specific channel, we want to funnel it into something called an AWS Lambda function. And this can also seem intimidating at first, but really it's pretty simple and it's just Python code. And so at a high level, what AWS Lambda is, it is a serverless computing service that allows you to run code without provisioning or managing servers. So it's much less lightweight than a server, and much cheaper and much simpler than a server. So really it's a simple thing. It's just we're funneling that data into an AWS Lambda, which is just a Python function in this case. That's literally all it is. And so once the Lambda receives the data in that Python code, we're going to tell this Lambda to upload that data directly to AWS DynamoDB. So that'll all be handled in that Python code. And that's only about 15 to 20 lines of Python code, really simple Python code. And so yeah, we'll be walking through all this step by step in detail. And by the end of it, you will be able to upload sensor data into AWS DynamoDB, and it's really cool. And as we mentioned, it has many powerful applications. So enough being said, I do not want to waste any of your time. Be sure to like, comment, subscribe, and let's get into it. Okay, so the first thing we're going to do is we are just going to start from the top down and create our DynamoDB database, and everything will lead from there. So in order to do that, just go to aws.amazon.com. If you haven't, go ahead and create a free account. I already have one, and I am just going to sign into the console here. And so the first thing you want to do is just go up here and search DynamoDB. It's a very simple step, and it's going to take a matter of seconds to create this table. So we just go create this table. I'm going to call it MPU6050. You can see it already suggested because I created that before. And we are going to create a partition key. So our partition key is essentially the primary key of the table, and that's pretty much the unique value you assign to each row so the table can distinguish the rows from each other, or in this case, the inputs. I shouldn't call them rows because this is a NoSQL database, but imagine each input should have some unique partition key value. What we're going to use today, I'm just going to call it point number, and point number is just the series of points I am measuring. So the first point would be point number 1, the second point would be point number 2, and so on. Really, you can make this anything you want, just depends on your name and what you want to assign as that unique value. Pretty much you want to guarantee it's going to be a unique value, otherwise your table will perhaps perhaps right over it, I believe. So make sure whatever you assign there is a unique value. So you can see I just called it point number. And so everything else we don't have to worry about right now. We could just go ahead and create this table. So as you see, really basic table just with a primary key, in this case, points number. And there we go. The first step is done. So you have your DynamoDB table. And so the next thing you want to do after you have your table is you want to create a Lambda function that has the capabilities to upload to this table. So in order to create a Lambda function, you could do it straight from here on the console. It makes it really easy. You could just search it. So we can just search it here, Lambda, with that intimidating symbol. And I don't have any Lambda functions yet, so we're just going to go ahead and create a Lambda function. Lambda function is just a piece of code that's lighter than a server. It's an event-driven code, so it's only triggered based on some external event that triggers it. So the function name, we'll just call it MPU 6050 to DB. Okay, we'll call it like that. And we are going to use Python 3.12. You can see there's many other runtimes you can use. So many options in AWS, which makes it so powerful, even Ruby, which I don't know how to use. So Python 3.12, you could just keep that architecture, change the function name however you like. If you're not using an MP6050, it's probably not fitting there. And then we could just go ahead and create the function. We're going to do it from scratch. Okay, let's go ahead and create the function. So give that a moment there. Okay, so now that our Lambda function is created, there's a bunch of options here, but we're just going to keep it simple today. We're just going to go down straight to the code, and you could see it has this nice editor for us here, which allows us to write Python code, and we're just going to edit the simple Lambda function .py. So I'm just going to show you this code I already used before, and I'm just going to paste it in here and explain what it is doing. And this is the code we'll be using in our Lambda function. So it's really simple. As you could see, I lied earlier. It's not 15 to 20 lines of code. It's about 30 lines of code, which is fine. So in this code, first of all, every time you have it, make sure you save and deploy when you have a change. So I just deployed it to this MPU6050 to DB. Okay, perfect. So I already know this code works, so it's fine. So what we're doing is we're importing Boto 3, which is the Amazon SDK for interacting with DynamoDB and I believe other resources in AWS. So we're just using Boto 3. We have date time. I don't think I'm actually using this anymore, so I could just go ahead and delete this. I was using this earlier for some testing for date time. And so we have this decimal, import decimal, so that's just for saving the acceleration in the x direction as a decimal value, just for some processing. We have some logging here just to do some debugging, just in case anything goes wrong. And so we set the logging here, as you could see. And the first thing we do is we create this DynamoDB object. And we have the table name, MPU6050, which is the table we just created. And so we just create this table object. And the main thing you want to focus on is this handler right here. So this is the Lambda handler. So pretty much in the Lambda function, you're going to pass it an event. So what is going to be passing an event? Well, the event is going to be passed from the IoT Core MQTT channel. So I'll show you how to do that in a second here. So in this event, pretty much what it is, it's a dictionary object. Okay, so if you worked with Python before, you probably worked with dictionaries. And because it's a dictionary object, we can just easily extract the values here, as you could see. So we're just doing some logging here just for debugging purposes again. We're going to log the value, or we're going to get the value from the event, so event value, and we're going to get the topic. So in MQTT, we have topics, so I am just going to add the topic in the event. And also I'm going to add the point number. Remember, we need a point number for each event because that is the unique partition key for the values in our DynamoDB table. So we are going to be sending essentially for every point we measure, it's going to have an AX as a value, it's going to have a topic number, and it's going to have a point number, okay? So just keep that in mind. It may be a little confusing now, but it'll make a lot more sense once we get to the MicroPython code. So we are extracting these two values from each point we send to this Lambda function. And so we are just going to do some more logging here, point number for debug purposes again. And finally, once we have that, we are just going to put the item into the table, point number as the point number we got from the event, acceleration in the x direction from the acceleration in the x direction we got from the value, and finally the topic. Okay, so this is a really simple way. And of course, depending on your data, you probably want to modify this slightly here. If you don't have acceleration in the x, maybe you're measuring humidity or that sort of thing. It should be quite similar, and hopefully it's you understand it enough to make those edits. So this is what we have for the Lambda function. We have some testing up here today. I don't necessarily want to go through that, but that just allows you to test it. I mean, we could just click that real quick and you could just send the event.json. So in this case, I would probably pass value and then point number and that sort of thing. So I'd pass in those 3 parameters. And if I click invoke, I should see a value actually in my table. So that's a good sanity check you can do to make sure everything is working well, okay? So now that we have this Lambda function, I'm just going to once more deploy it. Change is not deployed. So I believe everything is good here, okay? So now that we have this Lambda function, one thing that you're going to notice is you won't be able to upload straight from this Lambda function to the table. You actually have to adjust the roles of this Lambda function user because AWS assigns roles when you create a Lambda function. So let's just go to IAM in AWS. So this is how you manage access to AWS resources. So we're going to manage access from this Lambda function to this database. So I believe we could just go here, see if it's user groups, or I clicked this before. Okay, cool. So you just want to go down to these roles here, and you can see it automatically created us a role for that Lambda function we created. So MPU 6050 2DB role. So just go ahead and click that. Depending on yours, it should be named slightly different. And you can see it attach this policy. But really, we want to add more permissions here because this policy is not enough to upload to any database. So let's just go ahead and attach a policy. And we could just attach administrator access for the sake of this video. And I'm just going to add that permission. Okay. So now that role in this Lambda function now has the permission to upload to any table in AWS. So this is a really powerful role, administrator access. So if you were actually building a production application, you want to be wary of giving this to everyone. But for our sake in today's video, we're just going to give it administrator access to upload to that table. Okay, so far, what did we do? We created the DynamoDB table. We created the Lambda function. We haven't made the connection from Lambda to the IoT Core. So in the next step, what we're going to do is we are going to create the IoT Core setup. So let's just go ahead and do that here. Okay, so you could just go to the top once more, and let's just go to IoT Core. So we're almost done connecting things. We're getting closer on the AWS side of things. So I just entered the IoT Core service, AWS IoT. And this is pretty much the last layer of the service we'll be working with on the AWS side. Okay, so the first thing once you want to do is you want to, first of all, create a device here. Okay, so we could just go ahead and create things. Let's go ahead and create a thing. So we're working with a Raspberry Pi Pico W today, so we're just going to create a single thing. And this is the layer that our Raspberry Pi Pico W will be publishing data to. So we could just call it Pico W thing, okay? Of course, once again, there are dozens of configurations that you can play around with here for advanced purposes, but we're not going to get into that. And we are just going to generate a new certificate here. So this is important. So let's just go ahead and generate that certificate. And we have to create a policy as well for access for this thing. So let's go ahead and create a policy. So we are just going to be very lenient with this policy as well. We are just going to allow it to connect to any resource. So we could just add star here. And next we are going to allow it to publish to any resource. Okay. And let's just add 2 more here. We are going to allow it to subscribe, and we are going to allow it to connect, or not connect, receive. And so this pretty much allows our Pico W to publish or receive messages from any MQTT channel on this IoT service. So once again, really lenient just for the sake of the video to keep it simple. But these are the 4 main operations you typically do in MQTT. You connect, you publish, you subscribe, and you receive. So we're just going to create this policy, and we could just call it Pico W admin policy. So this Pico W will be able to do anything on AWS IoT. Okay, so we just go ahead and create that. Okay, perfect. So now let's just go back here. You could see the policy is there. So we have to attach a policy to that thing we just created, or else it'll have no access to AWS. So we could just go ahead and click create. And now what you want to do is you want to save these first four files here, because we're going to be copying them into the Pico folder in MicroPython. So just go ahead and save those and click done. Okay. And finally, the last bit of information you want to take from here, other than the certificates, is you just want to click settings, and there's an endpoint value that you want to copy and save locally. I'm not going to click it because that is personal information, but once you click settings, you should see that endpoint, and that is a unique endpoint to your iOS or your IoT endpoint on AWS. So keep that as secure as possible, and we are going to use that in the MicroPython code in the next step. Okay, so now that we have all that, the last thing we have to do on the AWS IoT Core is we actually have to create a messaging route. Okay, so this is the rule we're talking about in the architecture that connects this MQTT channel in AWS IoT Core to that Lambda function. So what are we going to do? We're just going to go here to messaging routes on the left, and we are going to create a rule. And we could just name this rule whatever we want. We're just going to call it Pico W to Lambda. So this is what is connecting the messages from the Pico W to that Lambda function. And we are just going to click next. So it's not letting me, so I'll just use a underscore. I always forget that. Let's go ahead and click next. And so what is it asking for here? It's saying, what would we like to select from which channel? And so what I'm going to say here is I'm just going to paste this SQL here. And so what we're saying in this rule is select star, that means everything from the MPU6050/AX channel. This is just the name of the MQTT topic or channel I'm using today. And so what we mean by that is we are just going to grab all the data every time it's published to that channel in this rule. So that's the SQL statement for the rule. So we're saying select star, select all from that specific topic, okay? So let's go ahead and click next. And so once we have this, that's going to give us the data from the Pico W. It says select an action. So we are just going to go here and select Lambda. Okay, so choose a Lambda function. I only have one. Okay, and that is it. So pretty much what we're saying is get all of the data from this MQTT channel and funnel it to this Lambda function every time you get data from there. That's all we are saying. So we could just go ahead and click next. Okay, review and create, everything looks good. And of course, in MQTT, you can have different topics and names. So you probably want to configure this based on the topics you're using. Once again, we're using MPU6050 accelerometer. Okay, so go down, and of course the Lambda function we have. Now we could just go ahead and create this. So once again, before we get into the MicroPython code, let's overview what we did. We just created a DynamoDB database from the top, and then followed by the DynamoDB database, we use that Lambda function to set up the intermediate layer between the IoT core and the DynamoDB database. And now finally what we did is we created this IoT setup we have here, where we have this rule that pretty much is telling Amazon, once you get data on this MPU6050 topic, just send it all to that Lambda function. Okay, that's all we're doing here in this IoT core setup. And of course, we have to do other things like get certificates for the device and create policies. But the main thing is here in this rule. So this rule is what is funneling the data to the next layers of AWS for processing. So I hope that makes sense. I know we just went over a lot on the AWS side, so please let me know in the comment section down below. Now that we are done with this, let's go to the MicroPython code and break that down and show you what we need in the setup in order to get this tunnel working. Okay, so now that we're pretty much done with the AWS side of things, let's just jump into our MicroPython environment for our Raspberry Pi Pico W. As you can see, I'm using Thonny with MicroPython to use as my editor, but really you can use any editor you want. I just prefer Thonny in this case And the first thing you want to do is you simply want to create a file. I just called it Pico W IoT Core example, and we're just going to go over this code we're going to be running on the device. But before you actually run the code on the device, the first thing you want to do is you just want to transfer those 4 files we downloaded from AWS. And so you could just go to the folder on the left here in the project manager in Thani. So this is your local. So I just downloaded it to downloads, and we are just going to upload those 4 files to the home directory of our Raspberry Pi Pico W. So I just uploaded them, and next what we're going to do is we want the MQTT client library. So let's just go to the lib folder on Raspberry Pi Pico W. If you do not have a lib folder, you can just go ahead and create one by creating a new directory, and lib folder is just where your Raspberry Pi Pico W stores libraries. So we could just go ahead and click create new file, and it's going to be called simple.py. This is the name of the file from the library. So we're just going to create that file, and we are just going to get the library code. So you just want to go to this link here, and I'm just going to copy all this. I'll link this in the description down below, but it's just one file code, as you can see here. And we're just going to paste that in, as simple as that. So now we have the MQTT client, we have the files we need in terms of the permissions. Let's go back to the home directory, and we could just close out that library, and let's go over this code at a high level of what is happening. Okay, so we have these imports here. We're not going to go over exactly what these imports are, but these imports are using the code. I guess most notably, we want the JSON import because we are working with JSON data when we upload to that MQTT channel. Other than that, just some pretty standard imports, SSL to manage the SSL certificate when we communicate with AWS. And down here, we just have the libraries we're going to use. So we have that simple file we just talked about, which we just created. If you are using the MPU6050, you're going to go and want to do this. I have another video on my channel where I talk about how to connect the MPU6050 to the Raspberry Pi Pico W. I'll link it right here, but I'm not going to go into that because really for this video, you can use any sensor you want. As long as you're getting some time series data, this is a good application for you. And machine to communicate with that MPU6050. And we have this config, so this is important, and some people in the comments always get confused about what this config is. In this config file, it's just a Python file with constants, and I just use it to save sensitive information. In this case, my internet name and password, as you can see here, come from that config file. Also, that endpoint I was talking about that you get from the settings tab in the IoT Core on AWS is also in that config. Remember I mentioned that is sensitive information. I just save that in that config, but really you can just make this a string if you like and hard code those in. Of course, keep that information as secret as possible. Now, what we have here as well is we have this client ID. So we just use this library ubin asci to get a unique client ID because when we are working with MQTT, we want to have a unique client ID to distinguish clients connecting to the MQTT broker. And now we have these file names here. As you can see, those are just the file names I have from the private key in the certificate. So you could just go ahead and copy those file names from your own files. You could just go to those files you downloaded and just copy those long file names. It's really long, so just copy it from there and just paste it into the code. And we also have this PEM. So this is just the path to the PEM file, as you can see down there on the bottom left. It should be the same for you. And we initialize connection to the MPU6050 there. And so we just define some functions here in this code. So the first one is just a function I got from some gentleman online to actually read and interpret these PEM files. So we can just copy that in. We're not going to go into the details about that, but it does some parsing and some processing to read those certificates and private key. And so next is we have this function to connect to the internet. So this function just connects to the internet based on your internet name and password. So if you have the correct internet name and password, this should be no issue for you. And this is also a really important function here. So this is the one that publishes to that channel. So what's going on here is we're just reading acceleration from the MPU6050. We're only taking one acceleration value from the MPU6050, but really there's 5 other values we can get on the MPU6050 in terms of acceleration and on the gyro and on the acceleration in the Y and the Z. But we're just keeping it simple for today's video, and we're just focusing on acceleration in the X direction. And so we're just going to set up a payload here. And so this payload is going to contain a point number, which is unique, and it's passed to this function. And it's going to contain a value, which is just the value of the acceleration. Okay, and it's going to contain a topic. And that's all we have in terms of the payload. We have to include the structure. Remember, we talked about that on the Lambda side where it's parsing based on the structure here. And just know if you change the structure, you're going to have to change the Lambda function accordingly. So that's pretty much what we're doing. And we're just publishing to that channel we talked about on the IoT Core. So IoT Core is waiting for messages on this channel. And based on that rule, it's going to funnel these JSON dumped payloads to that Lambda function. So that's what is going on here. So I hope everything is coming together now. Once again, a really simple function. We're just defining a simple dictionary, JSON dumping it to that MQTT channel. Here we just call it connect to internet. You should have no issues if your permissions are fine. Here we read those permission files, those long file names with that function read pem. We just pass in those file names above there. And then we start here with this MQTT client. So if you have the correct broker and you have the correct SSL certs, which you should, there should be no issue here. And you also have the CA, which is the CA file. If you pass in everything correctly, you should get a successful connection for this MQTT client, and you could start doing MQTT operations on your AWS IoT Core. So we just connect there, as you could see. And finally, what happens is for I in range 1 to 11, so that is we're going to publish values from 1 to 11. We're just going to print publishing for debugging purposes, and we are just going to publish MPU values. So we pass in I, so that is the point number. Remember, we talked about the point number has to be unique. And so it's going to publish point numbers 1 to 10 because 11 is not inclusive. And if we go ahead and run this code, we should see values in our database if we did everything right. So fingers crossed, let's go ahead and run this code now. So we are only publishing 10 values at a time. Really, I can make this 10,000. I can do whatever I want here. But just for the sake of this video, I just want to show you that I can publish 10 values seamlessly to DynamoDB. And it's really quick, surprisingly, although it's passing through all these services, which is cool. Let's go ahead and run this. And let's just give that a moment there. Okay, so let's see what the issue is online. I don't know what that issue is. Private PEM. Maybe I copied something in wrong. I don't know. Let's go ahead and run it again. Sometimes there's issues first time running it. Okay, give me a moment to debug off screen and I'll let you know what this issue is. Okay, so it took me about like 10 seconds to find that issue. So what I realized is when I copied the value in, for some reason it appended this value here because I moved it between directories. So let me just go ahead and edit that. So when you copy that PEM file, it should just be that. It shouldn't be all that other nonsense that you just saw there. And that should fix it. So let's go ahead and run this. Sorry about that. Okay. Oh, I have to re-upload it. So let me go ahead and delete that there. Go ahead and delete that. Let's go ahead and upload it. Okay, cool. So now this should work. So let's give it a moment to upload those 10 values. And the MPU 6050 reads values so quick that it should just take less than a second to publish all of those. Okay, so it published 1 to 10, awesome. So we see in the logs. And sometimes these logs can be deceiving because although sometimes it can publish to the MQTT channel successfully, sometimes that rule, when it passes it to the Lambda function, there may be some error there if you played with it because that's the intermediate layer and you may have messed up the Python code there. So keep that in mind. So just to confirm this is working as expected, let's go to AWS. Let's go to DynamoDB. So you could just search DynamoDB again, and we could just go to the left menu here and click Explore Items. So after we click Explore Items, we could just select this, and you could see we got 10 values here, which is awesome. Let's go ahead and delete this one more time. Let's try to upload 100 just to show you can do a bunch of values. Let's go ahead and delete these items. Okay, so I just want to show you how scalable this is. So let's just go back to the code, and let's just go to 101. So we're just going to upload 100 values back to back. And this can be really quick and just show you that this can handle a lot of data coming in at the same time with those Lambda functions and actually process it all. So go ahead and run this, give that a moment there, and it should upload it quickly. And once that is done, let's go back to the database. Let's just go ahead and refresh it. And we can see that it did upload it. So we have 50 items there, and on the next page we have another 50 items. So it looks like it did upload those 100 data points really quick. So you can just see how that low latency comes into play with AWS. And so finally, before I conclude this video, I just want to show you if you are having issues, if you're not seeing those values in the table, you can actually look at the logs for this really easily in AWS. And you could just go to, I think it's called Cloud. is it called Watcher? I forgot what the cloud service is called. It's called, let's search logs. CloudWatch. There we go. So let's go to CloudWatch. And then once you're in CloudWatch, you can just go to here and you can go to log groups. And in your log groups, see, I could just go to AWS Lambda MPU 6050 to DB. There's many different log groups. And we could just go and click through those streams and see what's going on. You should see the error here if you're not really seeing anything. Typically, it's an error in the way you configured your Lambda function. So if you played around with your Lambda function and you're not seeing values in the database, but you are uploading to MQTT, you'll probably see some errors here regarding that Python code, and you could just go ahead and edit and re-upload that Lambda function. So that pretty much concludes it for today's video. I hope you got the gist of how to upload data from your Raspberry Pi Pico W to AWS DynamoDB. Once again, a really powerful aspect of software engineering. And for you beginners who are watching this, if you got up to this point, give yourself a pat on the back, because this is a really valuable skill to have in this industry. And of course, hopefully you can use this to build some real powerful applications. So before we end it, if you like this video, if you learned something new, please like, comment, subscribe to the channel. And as always, even better, consider donating to the channel. I also have some consulting slots on my channel that you can book. If you are confused about anything or you want to work on a project together, you can go ahead and book that on the Buy Me a Coffee link in the description down below. Let me know if you have any questions. Again, stay tuned. Thanks for watching and take it easy. See you next time.